All right. So I guess let's get started. Okay, so this is our famous diagram. Any question on this, or shall we move on? So is it clear why we have propose, prepare, commit, and inform? Those basic phases are now instilled in our mind. We can move on. Okay, sounds good. So just some visual kind of, we have end replica. Let's say this is the set of non-faulty replica or the number of non-faulty replica. And in the non-faulty replica, these are all things we've seen before. In the number of non-faulty replica, let's say it's M. Among them, up to F can be Byzantine. So that means, as we talked before, anytime we form a core, up to F of them could be faulty. That means they could change their vote later on. So just a visual for that. Okay? And some arithmetic to kind of later we can get things done to make sure the number works. So what we talked about so far, we want our vote to be larger or equal to the number of non-faulty replica, or at least as bigger than the number of non-faulty replica, which is 12 plus 1. And so all our core that we talked about for prepare, commit, they are all at least 12 plus 1. With the exception from the client, we said, well, the client doesn't need 12 plus 1. It doesn't need to be greater than 2F as long as it is greater than F. So kind of just a recap. Why is it that client doesn't, how come we reduce it for the client? What was the rationale behind it? You talked about something last week too. Did you look into it more?
Yeah.
Okay.
That would just mean that it's one not replica that doesn't lie.
Okay, so we only need, when it's more than F, the only thing we can guarantee, again, similar to the previous diagram, if there's more than F, up to F of them could be faulty, that means one of them is honest. And if one of them is honest, then what it mean? What does it mean? If one of those votes inform vote is honest, what does it imply? No, but what is it? What can we get from that? If one vote, if you know one of the informed votes is an honest, how do we work our way back? How many, if I get one honest vote with client, how many honest replica would have been committed? Okay. Well, that's one prepared. Okay, and then what that gives us?
Plus one replica get same message or message from the.
Sure, but what's the significance of having 12 plus 1 prepared? No, you don't, to ensure uniqueness, you need a single prepared. You don't need 12 plus 1 prepared.
At least one has received it, it knows it's one.
So if you have, yeah, so exactly what it said. So if you have 12 plus 1 who are prepared, out of that 12 plus 1, how many of them are faulty? F are faulty. How many of them could later be inaccessible? I mean, potentially all of them could be inaccessible, but then nothing happens. But how many can be inaccessible while we can guarantee progress? F of them. Still one left. So that means one of those will have to be available, be accessible in order to any future progress to be made. And that one will ensure something that was prepared won't be lost. Questions? Clear? 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 Do you want to express it for me in your own words? On the spot. I'm gonna ask everybody. I just want to see how. Just want to express it in your own words. Think about it. I'm gonna start from you. Tell me your understanding of it.
Overall, there's 2 plus 1 messages.
Okay.
D,
Could be false. Okay.
and all of them be accessible, but they're nothing.
So why is it that only having one committed node is sufficient? Why is it just sufficient to get one node committed?
Because at least one of them is saying that the company was lying.
Well, here we already knew the primary is not lying. So why do we need one commitment? This we already knew. Think about it.
One that is honest commitment is enough to say that the majority of nodes are prepared.
Okay.
Because if we one on it, because there's always one next page, and then in the way that is already always might have to put the computer that I was one to inform the message to make sure the evaluation.
Okay. So change the question. What would happen if you would have asked the client instead of gathering F commit messages? What if we had asked the client to collect 2F plus 1 prepared messages? What do you think would happen in that case? Instead of saying right now, we're saying client to collect F messages, F inform messages, or F plus 1 inform messages. What if we tell the client instead to collect 2F plus 1 commit messages, not inform messages, commit messages? What would happen if just a client, we're already sending all these commit messages, let's say. What if we send it to the client? What if the client itself observed 2F plus 1 of these arrows? No, it's not. No, client is not a replica. I'm just saying client observes it as an observer. What can client conclude? If the client sees 2F plus 1 commit messages, what can the client observe? No. We're not talking about performance. What can a client conclude? We're not talking about performance. What is it? Would it be useful if the client were to observe 2F plus 1 commit messages? Any thoughts? I'm putting everybody on spot today. I've already done all of them anyway when you went out. Think about it. Coming back to you. What happens if the client collects 2F plus 1 commit messages? Not inform commit messages. Okay, that's a thought. But keep that thought. Think about it. It's not there yet. What do you think? Your thoughts? Yes.
States like you know that the channel to be off.
Yeah, so now what if client is also here. Let's say client is here. And it also receives all these messages. Client is here and it receives all the messages. It receives 12 plus 1 commit messages. Is that useful or not? I'm gonna go around like I just said. First, do you think would be useful?
Fair enough.
Okay, that is an answer. I'll come back to you since your hand is up. I'll come back to you last.
See. Yes.
Okay, yes, and why is it useful? Okay, think about it.
Yes, out there will become one, therefore, the receive plus one, the message, majority of the data are paired of the message. So, it should work.
Okay,
And I think no, because like the purpose of letting replica to reach the commit state and inform the client is to confirm that if there are like other recovery stage for other the one who is stand up could send this message on the replica. So I feel like
okay.
Think it's yes as well.
Business one,
Yes.
yes, is useful. And why is it useful?
I think it's kind of
What are we preparing?
yes.
We're preparing a dinner? Like, what are we preparing? I know this is called prepare, I'm just joking. Again, this I'm asking you because I want you to think. So I'm not examining you, I'm not testing you. I just want you to think. And I think you can think about it. Your hands up, I'll come to you last. So best thing is don't put your hands up. So I wanna, now you had your hands up.
So I think it should be the same as like the replica getting to plus prepare message. So like the replica get to you can send a message to the client. But when client get this, it means that like it guarantee that it is going to get a good message.
Good message, what's a
Like,
good
or-
message? What's a good message?
Correct, like
You had it, you did mention it.
bad.
No, you were saying the reason, forget about good. So what does it guarantee? If the client that here received 12 plus 1, what does it guarantee?
Then it's going to get some message.
No, that's a premise. It's gonna, what can it guarantee if it received 12 plus 1 messages? Is okay. Coming back to you.
messages unless you want first stage one,
What do you mean per first stage one what?
like majority of the same.
And so what is, if the client received 12 plus 1 commit messages, what can the client conclude about the state of the replica? If the client receives 12 plus 1 commit messages, not in form, what can it conclude about the state of all the replicas? Huh? Okay, more precisely. What can it say?
Like it's like no, I guess the percentage that are getting message.
Sure, but what can it say about the state of the replica? The form, but what, so let's say it receives messages from everybody. What can I say about R4? What's the state of R4? Prepared? What's the state of R3? R2? R1? So it knows all of them are prepared. What was the point of having reaching here?
No, everybody else is also prepared.
So
But
reaching,
you knows that all other replicas are prepared as well.
okay. You want to say something? You had your hands up?
Regards to full, you have one is redundant, it's redundant. It's almost like if you're asked to my contradiction, you probably want to example one fifty or one, but just enough. And if a single one, like you said, if a single one responds back to the line, if one of them is honest, that means one of them. Yeah, it tells that yes, 12+1, have the message blocked, have it prepared. Why would we just need the next?
No, 12+1 commit messages, not 12+1
Yeah.
inform.
2F+1 command.
Yes, messages, not inform messages.
We,
Yes, you're right. That's the redundant. Talking about what if the client was here? Here, we are here, put the client here, and we send this transaction to client, send commit messages to client. Not inform. What if we send 12+1 commit messages to client? Not inform message.
It's not just come out and tell them that there's two plus one of the replicas and they're not message like everything else. They just know that there's this locked.
Is that sufficient? Why?
They don't know whether or not they actually execute the transaction.
If the client, what if, before I send my commit message, I also execute the transaction? That will be your.
You execute it, you don't know whether or not other people have actually locked it in.
Yeah, I mean,
It's like,
not generic.
you don't know other nodes. I've also been like, you don't know what the other nodes have done. It's just like, they zoom in. You know how they put that, it's put it in there like saved memory, so like you can't like roll back. The thing.
so if you skip the commit stage, you don't ensure preservation, right? So even if you reach the prepare stage, you know that the primary is not lying. R4 knows that the primary is not lying.
So let me just do step by step. Useful or not? Yes or no?
Receives 12+1 messages?
Commit messages, not inform, commit messages.
Yes.
Okay, now, next statement.
The whole premise being that if the client receives 12+1 messages, it knows that all the replicas are prepared as well.
Yes,
And it doesn't, so if we don't want to guarantee, if we don't want to execute another step where.
forget about execution. Let's not worry about execution.
So let's say that you want to skip the commit stage and you don't want to know that if all the other replicas have also been locked or prepared, then you can go ahead and like execute it, put it after the prepare stage and then send it out to the client. But that would ensure that all the other replicas don't know if the other ones are prepared or locked.
So is there a problem there?
I think it's yes, like it's useful. It's my point.
But is there also a problem or no? Is it, you can, everything's fine?
Understand is how does it preserve it? at this
Okay,
point?
so let me just make this clarification. So far, what we've talked about is about ordering. We haven't really talked about execution. So we talked about ordering or deciding in this round, what's the transaction? We're reaching consensus on transaction. So once, for example, once we reach the commit stage, you could also not execute the transaction. Once it essentially says the next transaction is the transaction that she submitted is to buy a book. And then his transaction, her transaction, his transaction, and so forth. But we haven't talked about execution. So execution, it could be once I committed, once I know this is the transaction for this round, I can execute it and tell the client. So consensus is about ordering. Once you order it, everybody order in the same way, then you can execute it later. So let's kind of, just for sake of the conversation, to simplify it, not worry about execution. We only strictly worry about ordering, deciding what is the next transaction, deciding on what the next block is, not be concerned with the actual execution of the block. What does this observe once it reaches committed? One sentence. What does R4 observe? All the replicas are locked. Now, if the client at this point get the same messages as R4, what does the client observe? Identical or not? They're identical. They both observe that all the clients are, everything is locked. So that means you could drop the space. It's not necessary. But conditioned on observing, because essentially what we said before, that's why I kind of went back. What does F means more than F? One honest replica. Observed commitment. What does commitment means? One honest replica observed that the majority are locked. So the only thing that gets us preservation is that the majority are locked. Now, if the client also observed that the majority are locked, then that's it.
Can you repeat? You said again.
Okay. Why we said we need in F+1 inform, an extra inform? F+1 because we want to make sure at least there's one honest replica who committed. What's the point of knowing a single honest replica committed? It tells us majority are locked. What is the purpose of the majority are locked? Preservation. Now, whether a replica observes the majority are locked, or an external observer like a client sees that the majority are locked, you already got preservation. So preservation wasn't about getting to commitment. Preservation was about getting majority locked. Now, anyone can observe that. It could be client, it could be a replica. Yes.
I feel like there's a reason why this works that I'm just not understanding. Like, because it almost feels like we're not, like, the client is almost just being treated as if it's like, it's the same power as a replica.
Observe.
Yeah, it's observing it, but like, okay, the client observes 2M+1 are locked onto a message. But it's possible that the network just goes out or something, right?
But the point was 2M+1 being locked. That was our argument. To get preservation, our argument was enough people get locked. Even if nobody sees it, is there a tree in the forest if nobody sees it? Makes sense. I don't know.
But there's, okay, so I'm still like a little stuck, because like 2M+1 are locked.
But that wasn't a serious way. Is there a tree in a forest if nobody's looking at it? Therefore. But the thing is as long as there is preservation, even if a single replica gets prepared, it could get preserved, it could get locked in. The moment you pass the threshold of 2M+1 or 2M+1, then you know that it will be preserved. And that's all we want to be able to see. We want to see 2M+1 got to prepare state. Collecting his votes was a way of confirming it. But now that collection can be done by the client. Because if the client sees 2M+1 observed, then anytime anything happens, the 2M+1 are locked.
Just to confirm, so if saying we're stopping it from there, just sending 2M+1, that means in that point, the replicant is saying, I have to deliver this message. Not that
I'm prepared. I'm locked on it. This is essentially queuing.
yeah, that's why I'm
Yeah, that's essentially queuing. Yes.
So, in regards to POE.
That's another protocol, which is an instance of this, but that's the protocol that I described. The protocol is a later protocol that just says instead of having replica to observe commitment, let the client observe it and drops his face. So that's the protocol.
Yes, we are dropping the area commit. Well, not dropping it, we're there'll be future.
Okay, so I think that's a good point, but I want to make sure everybody understands that. So if we were to do execution here, so if the client sees, let me put it this way. If the client sees there are 12 plus 1 replica have been locked and say we're committed, does R4 also knows about this or no? So it is possible, so if the R4 were to execute that transaction and inform the client, or send the client message, send it to client, it might be the case that this was the only one who had got to the locked state. And later on, huge change happens, and since this was the only one who were locked, it gets dropped. So it's possible if there were, that's why I was excluding execution. If there was an execution here, there could have been a potential rollback of that execution. But if I had done execution here, I already know 12 plus 1 are locked. So this execution will not be rolled back. If I do execution here, there's a possibility of rollback. But if you not worry about execution, it's sufficient. But there is something. If I drop all of these and I just inform the client, then the client becomes the only person or the only entity in the system that knows definitively if a transaction is committed or not. So this will inform everybody a transaction is committed. But if I were to drop this and just inform the client, then the client is the only one who knows the transaction is definitively committed. Of course, there could be some other background process to keep everybody informed or bring everybody up to date. So we spend a month saying why this is necessary. Are we going to spend the next month saying why this is not necessary? All right, thank you. It's not necessary. You can drop it.